All right, folks, we are back with more constructors. This time we're looking at multiple constructors and how classes can have multiple constructors, like the rectangle class below. Now, each constructor uses different parameters. Here we have three different constructors, three different ways to construct rectangles, but each one has a different set of parameters. The first one has no parameters. The second one is a double for the length, and the third one has a double for length and a double for width. Each one of these constructs a rectangle object that will have the same behaviors that any other rectangle would have, but they give us more or less control over how we actually construct that rectangle. So let's play around with that and see how that would work. All right, so here I'm going to construct my first rectangle, and I'll just use new, the default constructor. Next up, we have a rectangle constructor where we actually pass in a double value. Now you notice I'm not typing double 2.0, I'm just typing in a double. The only reason here it actually calls it double is that this is where the constructor is defined, and in the definition of the constructor you have to specify, okay, we're going to be passing in a double and the name of it will be length or len. And then our third constructor for R3 is going to have a length and a width. All right, now we're going to try testing these out. We'll just print them. And as you know, programmers are lazy, so we always copy when we can. We'll print these three things out. Now, I'm sort of testing these out, playing around, seeing how these things work. But if you really want to dig into the details of, what this code does and how rectangles are constructed and how many constructors there are for different rectangles, you need to go look at the API. This is the description that's included with the adhesive shapes package. All right, so I'm going to compile my code, no errors, woohoo, and we try it. First rectangle has length 1 and width 1. Okay, so the default seems to be 1. Second one is length 2.0, width 2.0. That's actually a square, but as we know, a square is a rectangle. And the third one, R3, is length 3.0 and width 2.0. So as you can see, more specific in terms of controlling the actual state of our rectangle by using different constructors. Okay, so let's look at one other example of multiple constructors. In this example, we're actually creating a regular polygon. And here we have two constructors, and each one of them has a single parameter. One of them takes an int, and one of them takes a double. Now, you might be thinking, well, how is Java going to know which, constructor I want to be using if I'm only passing in one parameter? This is an important concept called overloading a constructor, where we have the same name, but because we have different data types, an int and a double, right? Data types, again, coming in very important here. It's going to figure out which one of these constructors to call based on what data type we passed in. Overloaded constructors can also be differentiated by the order in which the parameters are declared. So you'll notice in these two examples, the first one, we have a method that first takes an int and then the second parameter is a double. This next constructor would have a double as the first parameter and an int as the second parameter. The two constructors look similar, but Java is going to consider them to be different methods. And depending on how you pass in your parameters, it's going to decide which of these to call. So order, data type, and number of parameters are all different ways that you can overload and write multiple constructors for a given class. Now let's try playing around with a couple of these constructors. We'll delete this here. And we're going to create a regular polygon, call it poly equals new regular polygon and our int 3. And then we'll create another one equals new, and this time I'm going to pass in a double 3.0. All right, and then we'll print those out so we can have a look at them. And you might be thinking, how are we printing out shapes? Shapes can only be seen. You know, they should look like a shape, a drawing on the screen. Being able to print out an object actually requires writing a specific method in that class to tell it how to be printed. And you're going to learn more about that later. All right, so let's try compiling this. Compile looks good. When we run it, we have an equilateral triangle with side length 1.0. So you'll notice that this regular polygon used the number 3 as the number of sides. If I change this to 4, now we actually have a square with side length. So this int is actually determining the number of sides, whereas this side length is determining, see, it's still an equilateral triangle, it's determining the side length if it's a double. So in this case, the data type that we're using determines which constructor gets called, and that actually has a pretty major impact on how that information is used to construct a regular polygon. All right, it's time for you to get your hands dirty and dig into the shapes class and start constructing some shapes of your own. Good luck with the activities, and when we're moving forward, we're going to start to see how we actually call different methods from the shapes class. I hope that you enjoyed your little trip through geometry class. If you're saying to yourself, oh man, I really loved using all those shapes. Well, don't worry. You will have another chance to return to those shapes as we will continue to revisit this shapes package throughout other lessons in this course. But we use those shapes to give you quick access to this idea that you can use multiple constructors and you can construct the same type of object in multiple different ways. Let's link this back to our previous lesson where you learned about, or we talked about the blueprints for a house, the blueprint being the class and the house being the object. Remember that we talked about how there are different ways to create houses? Well, each one of those different ways to construct a house in your house class would be written as its own constructor. And so having these different constructors, even though they're all defining the same type of object, they can each construct that object in different ways. And remember, we call this overloaded constructors. Overloaded constructors means that you have multiple constructors in one class, and you can create those type of objects in lots of different ways.